This is Greg Paulson from Xometry, and did you know that Xometry.com has design guides for all the processes that it offers? Simply go to the resource page, click on Design Guides, and you'll find a listing of the design guides available. Always a good start is a production guide, which is a 2-pager per process that's offered, but we could dive deep into one of our individual design guides as well. So let's take a look at what we have. This is our design guide for preparing a file for 3D printing. What we talk about in this design guide are the technical considerations, including STL or mesh file resolution, as well as some common design tips just for 3D printing parts in general. I will also go over some details of build volume and other resources available at Xometry. So from a technical consideration, we don't mind at all you providing that native file, or a step export, or even a parasolid like XB. If you're running SolidWorks, we even take solid part files. If you're running things like Autodesk Inventor, we can take an IPT file. The goal of getting that solid file is that Xometry can take care of the conversion on our side and make sure that we're maintaining the quality and the purpose and intention of that part design, so we can actually export at different resolutions depending on the part's needs. If you do work in a mesh file format, make sure to follow these preferred file settings down below in order to get the best results from your 3D printed part. Files that are lower in resolution show more choppy edges, such as faceting, because STLs and mesh files themselves are made of a series of triangles. Higher resolution parts, those triangles are so small together that you don't necessarily see the features on the printed part, showing a smoother, more gradual transition in the surfaces. If you are dealing in mesh files, make sure to take a look at overlapping geometries and unify any bodies on this part. You may end up getting a Boolean error if you don't, which is where two bodies are overlapping, and that overlapped area essentially creates a void interpreted by the 3D printer. By merging them together, you'll get a solid part. In general, we recommend minimum thickness of at least 0.6 millimeters on any feature or design. That's including text itself. Usually if you're doing a supporting wall, try to go over a millimeter. Even 1.5 millimeters is a very good general practice. When parts are moving, so if you're using a powder bed fusion technique like SLS or HP Multijet Fusion, you actually may want to consider adding at least 0.5 millimeter gap clearance in those parts. That makes sure that the parts don't fuse together while sintering. If your parts are more dense together, you may also want to add a little bit extra to that clearance, maybe 10% or 20% more if you have the chance. That way that's going to prevent any over fusion from those parts' densities actually heating up and creating more of a fusion than typical. For confined hollows, you can use a process like FDM to actually make a less dense infill in your parts. Or if you do have confined hollow for SLA or for SLS, make sure that you are creating some sort of relief channel so that trapped support material can actually exit through the part. Fillets are always your friend. I can't recommend them enough. They're going to help give you better strength at any junction where you have a different shaped body against a stem feature. And of course, lightweighting is key with 3D printing. We're looking for purpose-built designs, and the more material you have, the more costly the part can be. By removing material through lightweighting, not only can you get the similar mechanical properties that you're looking for, but it also will cost less in 3D printing. Be mindful of build volumes. SLS about 13 inches is a good extent to keep in mind when you're designing for that process. FDM, we can build up to 36 inches. Just understand that there's a cost associated with that, and our platform is actually rectangular at that 24 by 36 inch. So for example, say I have a round plate and it's 27 inches round, I may actually have to section it off to get the best part possible versus leaning it up on the table, which can become cost prohibitive and cosmetically not as appealing. For DMLS parts, we recommend using about 1/4 of the platform to get a better economy of scale if you're building multiple parts. So that 2 to 3 inch range works really well. If you're building parts in sequence, then you can build parts up to 6 inches on the platform. As always, we have more design guides to come, and check out our live support FAQs, and you can even give us a call if you have any questions. You get instant pricing and lead times on all our processes at Xometry.com. Thank you so much.